একটু দেখো। So I am about to explain Bellman-Ford algorithm, which is still a single source shortest path. That means we start from single source. Okay. So for ease of understanding, I am taking a small graph. Imagine this is your graph. V1, V2.
স্যার দেখতে পাচ্ছি না।
ও শেয়ার করতে ভুলে গেছি। এন্টায়ার স্ক্রিন দেখে নাও, হয়েছে তো শেয়ার। আজকে আর কালকের মধ্যে তোমাদের পেন্ডিং বেশ বড় বড় তিনটে অ্যালগোরিদম আর অ্যাপ্লিকেশন দেখিয়ে দেবো, এর মধ্যে থেকে একটা দুটো পেতে পারো। মানে ইম্পর্টেন্ট, বেশ ভালো ভালো, মানে ইম্পর্টেন্ট খুব। দেখো আমরা শুরু করছি। 6 3 ব্যাস। So in front of you I have drawn a graph. Now the objective is single source shortest path. But now, as you already learned Dijkstra's algorithm, so you may get some similarities. But as the exams are quite near, we go for the easiest approach. In Bellman-Ford, whatever the graphs you try to focus on, Mr. Paul, proceed. The first step, you get your graph. Now, in Dijkstra, we focus on the vertices, and in Bellman-Ford, we focus on edges. These are the slight difference between these two approaches. So, first of all, prepare one identification of how many edges do you have. V1, V2, oblique V1, V3. Now, based on the given graph, I have identified all the edges. Remember that you need to count the total number of edges. As we obtain 5 edges, we have to repeat the process for 4 times. That means the rule is total number of edges minus 1 time you have to repeat the process. What process? Right now I am going to show you. So here, just like Dijkstra, it is single source shortest path. So V1 initialize to 0. Next what happens? For each of the vertices, we have to follow a specific procedure and you will obtain what is the process. Now see, from V1, if V1 and V2 edge 0 and 1. So in mind you calculate 0 plus 1 and you obtain 1. This will be initialized here. Next, we are evaluating for V1 and V3. So what happens? 0 plus 3. Here we get 0, then we get 3. And finally the resultant is 3. So assign 3 around here. So here, just observe that section. For edge V1 and V3, I already get a value 3. But for these V2 and V3, this place will be updated once again. For V2 and V3, there are 1 plus 1 and the value again updated to 2. Once again, for V1 and V3, we already updated V3 as 3, but for V2, V3, we start from V1 with 1, then 1, 1 plus 1, you get 2. Next step, the final one. For V3 and V4, we have to update again. V3 and V4, we have 2 plus 1, that means the V4 no longer remains 7, it will be updated to 3. Now, for second time again, we process the same evaluation upon this graph. So for V1 and V2, now just observe 0 and 1. Now there is one thing I forget to explain you. In the first step, except V1, all the vertices are set to infinity, just like Dijkstra's algorithm. So just observe this thing once again.